Everything around us is made of tiny particles called atoms. These atoms are the building blocks of matter, forming everything from the air we breathe to the stars in the sky. They are incredibly small, yet they hold immense power within their tiny structures. Atoms have a nucleus, and splitting this nucleus releases energy. This process is known as nuclear fission. When the nucleus of an atom splits, it releases a tremendous amount of energy, which can be harnessed for various purposes. That's nuclear fission, the heart of nuclear technology. This technology is used in nuclear reactors to generate electricity, providing a powerful source of energy that can power entire cities. This energy powers cities, but it requires careful control. Managing nuclear energy involves sophisticated technology and strict safety protocols to ensure that it is used safely and effectively. Nuclear technology is powerful, but safety is crucial. Engineers and scientists work tirelessly to maintain safety standards and prevent accidents, ensuring that the benefits of nuclear energy are realized without compromising safety. It's like fire, useful, but dangerous if mishandled. Just as fire can provide warmth and energy, but can also cause destruction if not controlled, nuclear energy must be managed with the utmost care. We've learned a lot about using it responsibly over the years. From the early days of nuclear research to the modern advancements, our understanding and capabilities have grown significantly. Scientists are always working on safer, more efficient ways to harness nuclear energy. Ongoing research and innovation continue to improve the safety and efficiency of nuclear power, promising a brighter and more sustainable future. Small-scale nuclear technology refers to smaller, more contained reactors. These reactors are designed to be compact and efficient, fitting into spaces that traditional reactors never could. Think of it like this: instead of a giant power plant, imagine a reactor the size of a refrigerator. This compact size allows for greater flexibility in where these reactors can be placed, making them ideal for a variety of settings. These smaller reactors could provide power to individual communities or even homes. Imagine a neighborhood where each house has its own power source, reducing the need for extensive power grids and infrastructure. They use less fuel and are designed with enhanced safety features. These safety features include advanced cooling systems and automatic shutdown mechanisms that activate in case of any irregularities. These features make them less prone to meltdowns and reduce the risk of radioactive material release. The design also includes multiple layers of containment to ensure that even in the unlikely event of a failure, the impact is minimal. Imagine a world where remote areas have access to clean, reliable energy. Small-scale reactors could bring sustainable power to places that are currently off the grid, transforming lives and boosting local economies. Nuclear technology has come a long way since its inception. From the first nuclear reactors used in research, we now have massive power plants generating electricity. However, the journey hasn't been without its challenges. Accidents like Chernobyl highlighted the importance of safety protocols and reactor design. These events led to stricter regulations and a push for safer alternatives. Small-scale reactors with their inherent safety features are a direct result of these lessons learned. Section 4. Powering our lives. Applications of small-scale nuclear technology. Imagine a world where hospitals have their own independent power sources, ensuring uninterrupted medical care. Picture remote villages, no longer reliant on unreliable grids, finally connected to the world. Small-scale nuclear technology could make this a reality. These reactors could power desalination plants, providing clean drinking water to areas facing shortages. They could even be used in space exploration, powering future missions to Mars and beyond. Section 5. Balancing the scales, benefits and risks. In this section, we delve into the intricate balance between the advantages and potential drawbacks of small-scale nuclear technology. Like any technology, small-scale nuclear technology has its pros and cons. It represents a significant leap in our quest for sustainable energy solutions. On the one hand, it offers clean energy, which is crucial in our fight against climate change. This technology can complement other renewable sources like solar and wind. Reduced reliance on fossil fuels means fewer greenhouse gas emissions, contributing to a healthier planet. Additionally, advanced safety features in modern reactors minimize the risk of accidents. It could revolutionize energy production, especially in remote areas where traditional power grids are not feasible. This can lead to improved living standards and economic growth in these regions. On the other hand, concerns about waste disposal and potential misuse remain. The long-term storage of nuclear waste poses significant challenges. While the amount of waste generated is significantly less compared to traditional nuclear reactors, it is still a critical issue that needs addressing. It still requires careful management to ensure that it does not pose a threat to the environment or public health. Effective waste management strategies are essential. Furthermore, ensuring these reactors don't fall into the wrong hands is paramount. Robust security measures are necessary to prevent any potential misuse or sabotage. Balancing these benefits and risks is crucial for the future of small-scale nuclear technology.